A challenge to our understanding of physics lies in the concept of superposition. Superposition describes particles existing in multiple states simultaneously until they are observed or interacted with. This phenomenon introduces bizarre and paradoxical properties, rooted in its undefined nature. For instance, particles seem to appear and disappear from existence, challenging the very continuity of reality itself. Even more perplexing is the thought experiment of Schrodringer's cat. In this scenario, the fate of a cat, either alive or dead, appears causally linked to a particle in an undefined state. Until the system is observed, the cat is in a superimposed state of being both alive and dead. This fundamentally challenges our conception of existence itself. One theory that attempts to resolve these paradoxes is the concept of discrete dimensionality. Discrete dimensionality proposes that particles exist in specific dimensional states, either in 1D, 2D, or 3D space. 3D space has three axes, x, y, and z coordinate. 2D space has two axes, x and y coordinates. 1D space has a single axis, the x coordinate. From the perspective of a 3D observer, the x-axis represents the origin or emergence of a structure. The y-axis represents the end or boundary of that structure, making it continuous. The z-axis adds depth, completing the structure in 3 dimensions. To be considered complete, a 3D structure requires all 3 coordinate. A 2D structure requires 2 coordinate. Without the z-axis, such a structure is infinitely thin, though still traceable and observable as continuous within 3D space. A 1D structure requires only the x-axis. Without y or z coordinates, it is perceived as discontinuous and appears to flicker in and out of existence from the perspective of a 3D observer. However, from its own 1D reference frame, the structure is well-defined and continuous. This framework offers an explanation for the strange behavior associated with superposition. A 1D structure has only a starting coordinate relative to a 3D reference frame. Its lack of y or z coordinates makes it discontinuous within 3D space. This discontinuity renders the structure untraceable from a 3D perspective, causing it to appear and disappear. However, within its own 1D reference frame, the structure remains entirely defined and continuous. This resolves the issue of Schrodringer's cat paradox, as superposition contains definitive, although untraceable properties. An analogy to clarify this concept is a flipbook. Each page of a flipbook represents a 2D matrix. A single dot on a page is analogous to a 1D structure. When flipping through the pages, the sequence of 2D layers projects a 3D experience of motion. If we mark a dot in the middle of the flipbook and flip through its pages, the dot seems to abruptly appear and disappear from view. This behavior mirrors how particles appear to flicker in and out of existence in our 3D reality, aligning with the concept of 1D structures. This theory also extends to explaining wave-particle duality, which I will address in a future section. Thank you for your attention.